In this quick demo, we're going to take a look at Gloo Mesh v2, which was just recently announced at SoloCon. In this diagram, you can see the architecture that we're going to be demoing. There's two clusters running Istio, which you can see here, and they're running the book info demo. Cluster 1 has the book info demo split up into two different namespaces, and cluster 2 does as well. And then we also have the Istio ingress gateway, which has actually been extended to be what we call Gloo Mesh gateway, which includes external auth, includes rate limiting, includes API gateway filters in the Envoy proxy like request and response transformation, web application firewalling, data loss prevention, proxy metric collection, these types of things. And all of this can be configured and managed from the Gloo Mesh management plane, which you see depicted in a third Kubernetes cluster down here. And those policies, security, traffic routing, north, south, east, west, rate limiting, all this stuff is ideally configured through declarative configuration and GitOps. Now, one of the new capabilities that we bring to Gloo Mesh v2 is an API for tenancy, multi-tenancy. And with this API, what we can do is we can stripe configurations and security boundaries across multiple clusters and namespaces for specific users. So if you're a development team, you can have a namespace set up for you that you own the configuration and traffic routing and policies for. You can also export those resources to other workspaces and take advantage of a hierarchical configuration model. In this case, we'll see that we have two workspaces, a workspace for managing the API gateways and a workspace for managing the book info demo, which is itself split out across a couple of namespaces. If we come to the book info demo, and if we refresh a couple of times, it should be pretty familiar. And then if we look at the Gloo Mesh UI, we should see we have our workspaces identified. And if we click into the workspaces, maybe the book info workspace, we can see an abbreviation of information, various policies, what services are available. If we click into the workspace, we can get even more detail about what services we can route to, what routing policies exist already, which are exported to other namespaces, which policies like rate limiting and these types of things might be in effect. Although they're deployed, they're not in effect yet, which we'll take a look at. And we can also see from the dashboard a multi-cluster view of the traffic flow in an environment like this. Like I said, everything is configured with declarative configuration. So Gloo Mesh v2 is 100% Kubernetes native, relies and uses custom resources to drive its configuration. And because we're using this configuration as data approach, we can use any tools to build the configs and then plug them into a GitOps pipeline. In this case, we have our configuration stored in Git, and then we're using Argo CD to actually deploy into our environment. So let's take a look at the first use case, which is we're going to control some of the rate limiting capabilities for our book info service. So if I come over here, we'll actually go to the command line for this particular part of the demo, and we call our product page. We're just going to take a look at the headers at the moment. We see we get HTTP 200. We can call it as many times as we want. But what we want to do is we want to set a rate limiting policy. And the policy that we want to set is for requests coming in with certain attributes and that get rate limited at most one request per minute. So these are the configurations for rate limiting. The policy we want to specify onto any routes that are labeled with a particular label. In this case, rate limited is true. And you'll see that Gloo Mesh's API is extremely flexible, where we can define reusable policies that can then be applied to routes or other objects using selectors. So in this case, we just need to add the rate limited is true label to our routing table. So let's take a look at that. Come into our editor, just use VI at the moment, and we'll find our route table that specifies traffic routing for the product page, and we'll add some labels. That was rate limit, rate limited is true. Let's verify that's what the label is. Yep, rate limited is true. Now we git add, git commit, rate limit, and git push. Now in our Git repo, if we refresh, we should see this change. We'll go to the route table. We should see this change was just added. Labels, rate limited there. And then we go to Argo CD, and we notice, if we refresh, that this workspace is out of date. So let's sync it following our Git ops approach, Git ops model. So I could click into the book info workspace, and we can see that everything is now all synced. So if I come back to the command line here and call it, here's one, and here's the second one, rate limited. So in this example, we used Gloo Mesh's north-south rate limiting capabilities with the Gloo Mesh API, and we enforced this across a virtual gateway, so it's deployed across multiple clusters. And we used a declarative configuration that's actually applicable to north-south and east-west traffic as well. Now this next part of the demo will show how to affect east-west traffic. So what we want to do is when we come over here and refresh a couple times, and we see that when we hit no stars or black stars, or maybe even red stars, that service calls the rating service. What we want to do is we want to inject some faults. Let's inject, here's our fault injection policy that says we'll inject a 2-second timeout, or delay rather, for this policy. And again, we can apply this policy by using labels and selectors. So let's add the fault injection label to our route table. So in this case, we're going to look at the ratings route table. So this is our east-west direction, same API as north-south. And we're going to add labels. We'll call this fault injection. That's true. So I'm going to do git add, git commit, following our GitOps workflow, added fault injection, git push. And we come to our Argo CD, we refresh, we see it's out of date, we see the ratings routing table is out of date, so let's sync it. And now when we refresh, we should see traffic delayed when it hits any of the backends that return stars by 2 seconds. If we refresh, we see it's hanging, and we get a response. If we refresh again, came back quickly because we have no stars. We refresh again, we see, oh, came back quickly. If we refresh, hangs, and we see black stars. So using the Gloo Mesh API, we can unify the application networking configuration for multiple clusters in the north, south, and east-west direction. We can enable strong tenancy and workspace isolation primitives. We can even do things like extending the capability of the data plane with WebAssembly and so on. So go ahead, check out Gloo v2, check out the rest of the talks at SoloCon, and thanks for stopping by this.